There we go.
So this is SkyWatchers, and we are doing a special meeting after 2 weeks since our last one, 2 weeks before our next one, on balloons, because we didn't want to wait. George and Jim were willing to do this about their involvement with high altitude balloons and pico balloons. And and we have quite a few participants. So, but don't count on me doing this every 2 weeks into the future. It's too much work. But anyway, so Carolyn's going to say a few words about her presentation in 2 weeks, and then we'll have Jim and George start their presentation.
Right. So a couple of weeks ago, tomorrow, actually, I went down to Broomfield and attended the Next Generation Suborbital Researchers Conference, which was the first one since before pandemic. The last one ended 3 days before everything shut down for pandemic. So it's been almost 3 years since we'd had one. And basically, I think a lot of suborbital science research kind of flies under the radar, so to speak. And so it comprises all of the suborbital flights that we see with Blue Origin and those guys, and Worldview, and also with rockets and balloons. I probably won't talk too much about balloons depending on what these guys talk about tonight, but I want to just give you guys an overview of some of the talks that we heard and some of the cool science that's being done. So that's on the 25th, I think. 2 weeks from tonight. Yeah. So there you go.
Okay. Okay. So just as a little introduction here to Jim and George, Jim Langsted and George Lehmkuhl, our presenters. We are really happy to have them talk about it. They'll tell you more, but they're ham radio operators and have been involved with these pico balloons and understand, and I guess involved with some of the other larger high altitude balloons. And both Jim and George worked at Rocky Flats. George is a chemical engineer before each of them retired. And Jim is with radiation and health safety, did you say?
Health physics.
Health physics, okay. So take it away. I guess George is going to show a 2-minute video, and then Jim will start his presentation.
Okay, I will I'll start the video in a bit here.
Okay.
But it's going to be a short video to kind of whet your appetite for all Jim's going to talk about. And this video will show check-in, fill, launch, burst, descent, and recovery of our EOSS balloons. Now, some of the pictures at first are in poor quality because my video program enlarged them, and when it did that, it made them poor quality, but you'll be able to see what's going on. And I will share screen here.
Is there audio to this, or are you?
There's some audio.
Okay. Okay. So where is this taking place, George?
All over the place.
Okay, these are an array.
They're all in Colorado. Okay, Jim is
Yeah.
gonna tell you about it.
Thank you. That's great to see the video. And Jim?
Let's see. There we go. See that?
Yeah.
Okay.
Can you go full screen with that? Or if not, I think that's fine. Yeah,
Well, it's as full screen as I can get, I think.
okay.
Yeah, that's pretty full.
Okay. What I'm going to talk about is the amateur radio aspect of high altitude ballooning, hobbyists primarily, and education. There are some professional ballooning programs, of course, and I think Carolyn probably saw some of that. And maybe we'll hear a little bit about that later. But first of all, what is amateur radio? You can listen on practically any frequency you want to, but if you want to transmit, there's only a limited amount of transmission that the general public can do. There's family radio and a couple of other low power or unlicensed transmitting like Wi-Fi. But what amateur radio, ham radio people can do is they're primarily experimentalists and hobbyists, but they have the ability to transmit on a limited number of, or a limited portion of many radio bands across the spectrum. And they use that for all sorts of things. There's a large group involved with public service, communications for races and parades and things like that, emergency services. During the 2013 floods, Lyons, Colorado was cut off from all communications for a couple of days, but hams were able to communicate and provide some communications. And then hams do all sorts of other stuff, including outdoor contests, and amateur television and flying balloons. George has been a ham for 65 years, started when he was just a youngster. And I'm a fairly newbie at the thing. I've only been at it for about 21 years. But so amateur radio is a neat hobby. There's probably about as many amateur radio licenses in the country as there are private pilot licenses, I've been told. What I'm going to talk about today is three aspects of ballooning. First of all, high altitude latex balloons, which the video just showed that aspect of the program. I'm going to talk about the daily weather balloons that the National Weather Service launches, not because it's amateur radio, but because there's a heck of a lot of them. And then I'm going to talk about pico balloons, which is a popular subject right now, especially with the military. So let's talk about high altitude latex balloons, essentially the poor man's space program. Here's a chance to get students' payloads up to about 100,000 feet into rarefied atmosphere, somewhat space-like conditions, cold, and a big chance to do that. We use large latex balloons. That balloon's about 9 feet in diameter, about 16 feet tall. What happens here? It's either a hydrogen or a helium-filled latex balloon. A controlled ascent. We fill it with enough gas that it goes up at a reasonable rate of speed so that it doesn't float too far out into Kansas. But on the other hand, gets up to a good high altitude. The balloon then bursts and it comes back down on a parachute. You can see in this picture, the orange parachute is just held by the tip of the parachute underneath the balloon. It's tracked and then recovered by the amateur radio people so that we can get the student payloads back to the students. On the balloon, we have GPS tracking beacons that report via amateur radio the position of the balloon and the altitude. And we also have on it a cut down mechanism such that if it were to go awry, either too far or start to drift into DIA airspace or something, we could cut the balloon loose from the parachute and terminate the flight. The communications are done on the 2-meter ham band. the history of the ballooning, it started here in the US back in about 1986. A gentleman named Bill Brown, we call him the father of amateur radio ballooning, and he's still very, very active in it, launched a balloon from Ohio. And he was involved with amateur television and was trying to figure out how to get a camera up to high altitude so he could see, the edge of space. And in 1990, there was an amateur television group here in Denver. They called themselves the Western Vision Network. And they were trying to figure out what to do with their cameras. So somebody said, hey, let's put it on a balloon. And they flew a balloon and beamed pictures back down. And it was successful. And they did 2 or 3 more. And this group morphed into a club called Edge of Space Sciences. And that's the club that George and I are both involved with and has been going ever since then. I've been involved with them for about 200 balloons that we've launched, and I've been involved with most of those. Okay, the equipment that we use for the balloons, we use 2 different size balloons depending on what we need to carry. One is about 3,000 grams of latex. That was the big one that you saw in the picture. It starts out 9 feet in diameter on the ground, and as it goes up, of course, it expands, and its burst diameter is about 43 feet in diameter. So it gets fairly big, and it gets up to around 100,000 feet. Now, we also use a smaller balloon, 1,500 grams of latex. It inflates to about 6 feet in diameter and bursts at about 31 feet in diameter. It gets up about 95,000 feet generally. Quality control on these balloons isn't all that great. So they burst plus or minus 20,000 feet of 100,000. The tracking beacons, you can see that picture in the upper left there. We build those. They have a ham radio in them, antenna connector on the top. They have a GPS inside them. To keep them light, the case that's around them is made out of foam core boards such as you buy at Hobby Lobby. Put a plastic skin on the outside of it that helps with the integrity. And it has batteries, will transmit for about 24 hours. So if it lands, we have a good chance of getting it. You can see down at the bottom here, student payloads that are all laid out, ready to go. Students will often build these university programs. They spend a whole semester building them. And, getting college students out at 7 o'clock in the morning or 6 o'clock in the morning is a chore, but they're usually excited enough that they come out for the launch and have a good time. And then for tracking and recovery, we have a small computer that we carry in our car, plug a GPS into it so it can tell where it is. I have a small radio receiver. It's actually called a software-defined radio. It's just plugs into a USB port and receives the signals, and the computer processes the data and puts it on a map that we can look at. Okay, the purpose of the programs it has evolved pretty much into STEM support programs. We support elementary programs, middle school, high school programs, and college programs. CU Boulder uses this as a freshman introduction to engineering. They go through the whole engineering process of objectives, preliminary design, final design, flight readiness review for their aerospace program. And they also do a program for non-aerospace people. And then in various years, we've also done program or flights for other groups like LASP down in Boulder. We've flown some equipment for them, including one they wanted to fly at night. So we had to get special authorization from the FAA, put strobes on it. And we've also flown packages for NOAA. NOAA developed a atmospheric sounding sampling program. We flew it for many flights while they got it finalized, and then they took over or started their own balloon program. And once a week out of Boulder, they fly a ozone sampling system using some of the knowledge they learned from us. Picture on the bottom there is when it lands out in the field. We try to get the students out to the landing site so they can retrieve their own experiments and go through the whole process. Okay, what's the flight profile look like? On the left there is a chart of the altitude. It essentially goes up at about 1,000 feet per minute, maybe 1,300 feet per minute, to altitude where the balloon bursts. This one looks like it burst at about 93,000 feet, and then it comes down on the parachute. Parachute, of course, doesn't have much wind to bite in or air to bite into at 90,000 feet. So it comes down pretty fast at first, and then it slows down. That's an exponential curve that corresponds with the density of the air as the balloon comes down. And then the map on the right shows where one of our balloons went recently. We launched from Deer Trail, Colorado, out to the east of Denver, mainly because we get east of DIA airspace. Then when the balloon flies, it doesn't fly through the DIA airspace. And we communicate with the FAA so they know where it is. But in this case, it went up, and at high altitudes, the wind shifted to the south. And then as it came back down, it went back to the west, and it landed out in a little town called Cope, Colorado. One thing neat about this is I've learned a lot about Eastern Colorado. Visual observation, you can see the balloon from the ground. If it's a clear day, you can look up there, and it gets bigger as it goes up, of course, and it's white against the blue sky. This picture was taken with a 300 millimeter, 55 to 300 millimeter zoom lens, but she was fortunate enough to be taking a picture right when the balloon burst and caught the debris. That's kind of unusual, but this is a little bit of a worry. If balloons are high on the public's radar these days, so to speak, could possibly look up and see something like this and be worried about it. Normally, we notify the sheriff in the county where we predict we're going to land. We tell them, we're going to have 12 cars out there running around looking for this balloon. So if somebody sees a whole bunch of vehicles and calls it in, you'll know what it is. They appreciate that. But we think this next flight, we're probably going to notify all the sheriffs along the counties that we fly through in case something like this happens. Okay, the communications protocol that we use is kind of interesting. Back in the early 80s, there was something called automatic packet reporting system developed, and it's a ham radio system that takes in GPS data, processes it, puts together a little packet, and sends it out on 2 meters. And it was developed by senior research scientists at the Naval Academy, and they used it for tracking races that they were participating in. They had a 100-mile endurance run, and they put these beacons on the horses that were part of the run, I guess, and were able to keep track of where the run was going, or where the people were. In Denver here, they use it for some of the bike races to show where the sag wagon is, where the various support vehicles are, where the leader is, etc. And you can see it, you can see on the right there, these people put these in their cars and show where they're driving around. I don't know, so their wife can keep track of them, or other hams, or what. But you can see the tracks there as various drivers have driven around. And at the end of the track, you'll see a little symbol of a car. That's where they're currently at. And it'll have their call sign right next to them. And on the bottom there is a example of the data packet that comes out. And the yellow bars show, the first one is the time. The second one is the latitude. The third one is the longitude. and the fourth one is the altitude. So we like that for the ballooning, and every 30 seconds, the beacon on our balloon will send down this information, and we can track where the balloon is going. We also put that data out on the internet and make it available for the FAA. They can look on the internet and see where the balloon is. They were not able to actually see it on their screens until recently when we upgraded a little bit. For tracking and recovery, when we go out to get it, one thing that's very useful in the upper top is a pre-flight prediction. The weather models predict the weather at various levels of altitude, and they put that on the web and make it available. You download that data, and then you float the balloon up through that wind field, and you can predict where the balloon is going to go. And where it changes from green to red there is where the balloon bursts, and then the red is the descent as it comes down using a parachute model. So we get a good idea of where it's going to go. I always say that's plus or minus like 20 miles. Then on the bottom is a picture of what we see on the screen in our car with some labels on it. But you can see that there's two balloons flying in the upper left-hand corner of the map there. One is red and one is green. It shows what the names of their beacons are. And then the dotted line is the predicted path that we expect that balloon is going to take. And this is a different one than the one up above, but you can see it goes up high and then it goes south for a while, and then it goes bursts, and then it goes back to the southeast. So we can compare the balloon with the prediction, and that'll tell us roughly where it's going to land. We have people out in the field with these in their car, and they usually get close enough to actually see it coming down. Okay, so what is the danger of these balloons as far as aviation is concerned? You know, that was given as one of the big concerns with the Chinese balloon, but if it was in fact 200 feet tall, that's one thing. But these smaller balloons, what's the danger there? Well, I'm going to show you what the FAA regulations are, and presumably these regulations were written with airline safety in mind and the appropriate analyses done. But first of all, the general duty clause says no person may operate an unmanned free balloon in a manner creating a hazard to other persons or their property. And so if they can't get you on anything else, they could get you on that if they needed to. Also, the regulation says no person is allowed to drop an object if it's dangerous to anyone else. And we always have students that say, oh yeah, we'd like to release a glider or something like that. Now, nothing more than a paper airplane. Okay, then the regulations say if you meet certain small balloon requirements, you're not subject to any other regulations. And the small balloon requirements are that no one package is more than 6 pounds, and that if a package is greater than 4 pounds, the weight to size ratio can't be more than 3 ounces per square inch. The first one, I assume, has something to do with the size of a goose getting sucked into a jet engine. And the second one, I'm guessing, has something to do with colliding into the windscreen or the windshield on an airliner. Then if the flight string has 2 or more packages, which most of ours do, the total weight cannot be more than 12 pounds. And then finally, the rope requires an impact force of 50 pounds in order to separate the payload from the balloon. So they say if you are less than these requirements, you can go ahead and fly the balloon. No other FAA regulations apply, and we don't need to be notified. That's the category that pico balloons fall into. That's the category that most amateur balloons fall into. It's only when we start putting together these big ones with university programs on them that we exceed that. And if we do exceed that, they have a bunch of requirements that we must follow. And you can tell these are all airline related. If you're less than 2,000 feet, you can't fly through Class B, Class C, Class D, or Class E airspace around an airport. You can't fly through skies that with clouds greater than 5/10 cloud cover. If you're below 60,000 feet, your visibility has to be greater than 5 miles. And if in the first 1,000 feet, you cannot fly over congested areas of cities or open air assemblies. Now, what I'm doing is summarizing the requirements here. So if you're actually going to do this, don't take my word for it here. You got to read the requirements. But then there's also marking requirements for a balloon if it's big enough. Well, first of all, the equipment has to have 2 independent cut down systems. You have to have a radar reflective device capable of vision by surface radar. You have to either fly in the daytime or at night. You have to have lights that are visible at least 5 miles. If you have a trailing antenna that hangs down longer than 50 feet, it needs to be either break with a impact force of 50 pounds, or it has to have colored pennants and streamers from it. And if you have a suspension device, I'm not sure what that is, that's longer than 50 feet, you have to have alternate colors or colored pennants or streamers. I think that would be if you had a long rope between the payload and the balloon. And then one more set of requirements. If you do have a big balloon, you need to notify the FAA, and that's the nearest air traffic control. And they ask that you give them a pre-launch notice, and they list a bunch of information that they want in that pre-launch notice. They want to know if you cancel the flight that you were planning to do. They want a notice when you launch, and they also want a notice at the end of your operations. And then while the balloon is flying, every 2 hours, they want a position report reported to air traffic control. And then 1 hour before descent, they want you to forecast the descent trajectory and send that to them. So you can tell that they have the potential to know where these balloons are and know where they are in relation to traffic. The way Edge of Space Sciences has done this, we do all the notifications, and we have put out on the web in the language that the air traffic control people like, how far from the VORs and how many nautical miles and magnetic direction from the VOR to the balloon. And we've given them a projected trajectory. And then it also reports on an ongoing basis where it is. There is a piece of equipment that all planes are required to fly now called ADS-B. I'm not sure what that stands for, but it's a continually reporting system. We have recently been flying those on our balloons, and FAA has come to appreciate that being on the balloons, and then they can actually see their balloon on the scope or see our balloon on their scope while we're flying. Unfortunately, these ADS-B units are heavy. They do make them for drones, so they are getting pretty light now. They're expensive. They're about $2,500, and for most school programs and things like that, $2,500 is prohibitive. But we're fearful that the regulations may go to requiring that, but we have been doing that. Okay, so that is high altitude latex balloons. Any questions on that? Okay, let me go on to another kind of balloon. And these are the weather balloons that the National Weather Service in multiple countries launch. This is not an amateur radio activity, but it is fun for us. We spend some time, watching these things. We also, this is also concerning in that there are so many of them that fly. Now what they are, they're hydrogen or helium filled latex balloons, controlled ascent up to where the balloon bursts, a parachute descent. They have a radio sonde, which is the beacon that's on the balloon, and it reports upper air data, pressure, temperature, relative humidity, and the GPS position. And it transmits down either on 1680 megahertz or 400 megahertz communication. These are a couple of bands that are used for weather equipment. If you look at the picture on the right, the balloon is smaller than the other balloon, the previous balloon we saw, but it has a small parachute, has a very long string, 75 to 150 feet. And then it has a small beacon down at the bottom. And the beacon down at the bottom has the weather sensing instrumentation in it, as well as the radio and GPS. Now, where are these things launched from? Since the late 30s, they've been used to take atmospheric soundings, and there's over 1,300 upper air stations worldwide. The upper picture there shows where they are, and these people, National Weather Service has 92 of those locations, and you can see the map there on the bottom with the code, 3-letter codes for those stations. But they launch 2 balloons a day, one at 00 Zulu or UTC and one at 1200 UTC. Across the world, they're all launched at the same time. But here's 2 balloons a day from 92 locations in the United States where balloons are going airborne. These are small balloons. They're not subject to FAA regulation, but they let them go. And sometimes they fly right over DIA. Sometimes they fly right through the airline or air paths, and it's pretty extensive. Okay, what is the equipment like on these? Well, the balloon here starts out about 5 feet in diameter, and it goes up to about 25 feet in diameter, and it bursts at about 100,000 feet. The radio sonde that hangs under it is very small. It only weighs 250 grams to 500 grams. So that's about half a pound, or 9 ounces to 18 ounces in size. And you can see the pictures on the right there. The things are essentially cardboard and styrofoam cases. They have the temperature sensor sticking out the side, and then inside, of course, is a circuit board with some batteries on it. And the parachute that they use is a 48-inch piece of plastic with cotton string on it. And when these balloons come down, the Weather Service does not track them or recover them. They just let them go. They have a little notice on them that says, if you find this, it's not dangerous, just dispose of it properly. Okay, the purpose of the atmospheric sounding is for the National Weather Service to collect data. And they put together this weird ass graph. It's called a skew T chart. And you can see that the temperature lines run diagonally from the bottom to the upper right. And so the temperature is skewed to the right, and on the y-axis, that is the pressure instead of altitude. Well, they have the altitude there in meters, but the pressure in millibars. And what they are doing is collecting data for the weather models. This goes into the weather models, and then since it's reporting GPS, you can also look over on the right there and you can see the wind direction. Those are wind directions and wind speed. You know, the little tick marks indicate the wind speed. And this information provides meteorologists with quite a bit of stuff. I've been told that if you understand this chart, and I'm far from it, that you'll understand meteorology very well. Okay, what's the flight profile like on these? Well, it's very similar to the latex balloons that EOSS launches because it's essentially the same kind of equipment. You can see here that it's going up, and its altitude is in meters, not in feet, of course, and comes down on a parachute essentially the same way. And the flight path that it takes depends on the weather, but it's essentially the same kind of thing. You know, we're talking 70 to 100 miles. This particular balloon that we're looking at here was launched at Crested Butte, right above Crested Butte at Gothic, Colorado. They are doing a 2-year mountain weather study. And as part of that, they're launching 2 balloons a day from there. And I keep waiting for them. That's me over there, the little blue guy in Denver. And I keep waiting for the wind to be strong enough to blow them over here into Denver. And then I run out and chase them. And the way I chase them is I have a radio in my car. And here I'm using a Raspberry Pi with software that some smart guys in Australia have written. Has a GPS on it, has the little software-defined radio antenna. Put this in the car, it generates a Wi-Fi signal. I can look at my tablet. Not as I'm driving along. I always pull over, park, put on the emergency brake before I look at the tablet. But anyway, I can track the balloon and go out and chase it. Again, we use predictions. Here's a whole week's worth of predictions for the balloon that's going to be launched from Grand Junction and where all those balloons are going to land. And then in my car, on my tablet or my computer, I have a map like this, and it shows where the balloon started, where it's gone up to, where it is right now. And then the blue shows where it's going to predict it to land if it bursts at 100,000 feet. But if it were to burst right now and start to come down, here's where it's going to land. So with that, I can get in my car and I can take off and start driving and get out there and be under it. And if I'm lucky, catch it with a catcher's mitt. Never have actually done that, but. Okay, and here's ham radio people or interested radio people monitoring weather balloons all over the world. And they put it on the web, and there's a place that collects all this data. But here's weather balloons that are all being tracked by various receiver folks. A lot of people will set up that Raspberry Pi at their house with a antenna on the roof and put it into the web, and it'll report to this place. So it's a lot of interest in this sort of stuff. And it's also fun to go out in the field and catch them, collect them. You know, we go out in the field, and unfortunately, it's usually about 6:30 in the morning. So you don't want to knock on the farmer's door. So you make a quick trip out into his field, pack it up, and get out before they discover you. With Edge of Space Sciences, we're much more careful about that. We do get landowner permission before we take the students out onto the land. Okay, now pico balloons. The reason pico balloons are interesting is because it is suspected that the one that was shot down by the military over the Yukon was one of these pico balloons, just like this guy is holding here. And they think the one that was over Alaska may very well have been one too. I'll tell you about the program and then how we think that's the case. But the neat part about pico balloons is around the world. If things go well, you can go around the world in about 14 days. And if the balloon survives and doesn't get taken down in a thunderstorm, it can go, I think the record is probably 7 or 8 times around the world. That is Bill Brown, the father of ballooning, and I think he actually developed this pico ballooning process as well. Back in the early 2000s, there were people that were trying to fly balloons across amateur balloons across the Atlantic Ocean, you know, and they would try and they would get out in the ocean. They couldn't hear where they were, and they hoped they pick them up over in Europe. And finally succeeded in doing that, but then they came up with this pico balloon process. Okay, the overview of how a pico balloon works is you take an inexpensive balloon. Inexpensive meaning those foil balloons cost $2 or $3 a piece. You can get them, Walmart party balloon, or you get them from Qualcomm, which is a science supply, and they have a little more quality assurance associated with them. Now, this is a super pressure balloon, which means rather than going up high, popping, and then coming down on a parachute, it goes up to an altitude and the balloon expands, but when it gets tight, it's strong enough that it holds itself together. And since it can't expand anymore, it can't rise anymore. And so it levels off at an altitude. And these have been planned to go up to about 35,000 to 40,000 feet, level off, and then they'll be in the jet stream, if you're lucky, and away they go. At 40,000 feet, you're above the top of most thunderstorms and can get over the top of those. Sometimes a big thunderstorm will go up to 50,000 feet or whatever, and then that's a problem. So you can use these Mylar party balloons, Mylar balloons, or Scientific Balloon Systems in California developed a balloon with UV resistant plastic. And this balloon's about 2 feet in diameter and about 7 feet long. And it'll float up at about 40,000 feet, which is a little bit better because it's above a few more thunderstorms. But in order to fly these things, you can't have a payload on them that weighs more than a fraction of an ounce, because if you do, it won't go high enough without going to a much more expensive balloon. The other problem with these balloons is they rise and fall with daylight heating. Heat up in the morning and they'll rise up and they'll go 2,000 or 3,000. No, they'll go, plus or minus 2,000 or 3,000 feet from where they normally float. So at night, they'll cool off and they'll sink down. And in the morning, they'll start to warm up. Once the sun hits them, they'll climb back up. And there's a couple of different transmission protocols that you can use with these balloons. I wasn't able to get much on the history of it, so there you go. Okay, the balloon size, 36-inch Mylar balloon, or this 2 foot by 7.5 foot plastic balloon. Interestingly, the plastic that this guy came up with to use is what the Japanese use to wrap sushi.
Yeah.
Why or how he discovered that's the right kind of plastic to use, I don't know. But, and unfortunately, you can only buy it in like 1,000-foot rolls. And so you can't buy it and make it at home. But so they're selling, unfortunately, they charge about $150 for these. So they're a little more expensive. Then the beacon, like I said, has to be very lightweight. And let's see, I've got one right here. You can see it, and the picture is actually better there. It's solar powered. Batteries are too heavy. It's thin circuit board. This only half a millimeter thick circuit board with the surface mount electronics on it. Has an antenna connector there on the bottom. And to even save weight, you can unsolder that connector and take it off when you solder on the wire. But this whole thing only weighs 12 grams, and that's about 1/3 of an ounce. And this thing will transmit its position. It has GPS in it. And while the sun is hitting the solar panels, it'll transmit once every 10 minutes its position. Okay, here's an example of a flight that we did. I'm not a pico ballooning expert. I've only flown one, and this was it. We launched from a conference we were at in Boise, Idaho. And the red dots are the position transmissions every 10 minutes. And then during the night, it went silent because it was solar powered and it floated up to here. And then the next morning, it picked up again and it started transmitting, and it was going a little faster. So the dots are a little further apart. And then that night it went back to sleep, woke up the next morning, transmitted. And so this whole path is about 12,000 miles long. It went up over Canada, down through Newfoundland, and then it was about 1,200 miles off the coast, the Atlantic coast of the US. And it flew down here. It obviously didn't get into the jet stream, but it flew down here, and then it got caught in the Bermuda Triangle. This is in fact a stormy, it was a stormy season, and you can see how it circled around. And here's the weather patterns that were going on in that area at the time. You can see the circular wind patterns, and the thing circled around, and we watched it every 10 minutes start to get lower and lower and lower. And we thought, oh, this is it. And then it went dark at night. And so we thought, well, that's it. Anyway, the next morning, an email popped up from one of our members. He says, it's alive. And so it went down, maybe even touched the water. We don't know. But it came back up, lasted for another day, and then it disappeared. So anyway, that was our experience.
Hey, quick question there, Jim.
Yeah.
When you're tracking something that's going that kind of distance, can you as an individual ham receive that signal, or do you rely on a network of ham people around the globe to be picking up that signal?
Well, I can receive it if it's up over the top of me, but otherwise I have to rely on the a network of people. And
okay.
Dewey, I'll show you that right after I show you. This was one of Bill Brown's flights, and it went around the world, I think 7.5 times before it finally disappeared. He lives in Huntsville, Alabama. So it started here and it went around the world. Once it went north up into the Arctic, but went around the world, and it finally disappeared somewhere over Western Africa, probably in a thunderstorm. But
how powerful is that transmitter?
20 milliwatts. Okay, now here's the deal. Remember I talked about APRS that was done on 2 meters, and it had the GPS and it put the data together and it sends it out. Unfortunately, 2 meters is only good for about 150 miles. And so here's an example of a balloon that was flying over Turkey, and it went up north, kind of circled around a little bit in the wind here, but it went up over, and it finally got out over the Black Sea far enough that it was away from anybody that was receiving it in the reporting network, and they quit receiving it. Now, it doesn't mean the balloon went away. It's just that they couldn't receive it anymore. And the first people that were flying across the Atlantic, what would happen is they would launch it. It would work its way across the US, and then it would start to go out over the Atlantic Ocean, and they could hear it for about, or somebody could hear it for about the first 150 miles, and then it would disappear. And then it would be about 3 days, and they'd call the guys over in the Azore Islands and say, can you hear it? Can you hear it? And finally, one was successful, and the guys in the Azores picked it up, and that was a great success. So APRS has the trouble, their 2 meters has the trouble that this will disappear when it gets 150 miles away. Then maybe you'll pick it up over Russia, 2 days later. But there's another protocol that you can use, and another band that you can use called WSPR. WSPR stands for Weak Signal Propagation Reporter. And what it is, it's a network of hams around the world that have a receiver, and they connect it into the internet, and they listen on a particular frequency and on each band. And this guy in the center there, he probably in the Canary Islands, he had put up an antenna, and he wanted to see how well the antenna worked. So he started transmitting a WSPR signal, and these various stations around the world decoded that signal and then put it out on the internet, and they said, yep, we can hear you here. So if this system works, why not put that on a balloon and then fly it? And when the people say, hey, I can hear you, you tell them your position and they can report that, and you can tell where the balloon is. And this is not on 2 meters, this is on 20 meters. So it's a different band where signals will travel a lot farther. And so the little sky tracker, like I showed you in the picture earlier, I took mine and I plugged it into a 20-meter antenna here at my house up in Coal Creek Canyon, and I turned it on, and it's transmitting 20 milliwatts. And people all around the US were picking up my signal. In fact, at one point, somebody over in Europe actually heard my signal. Okay, so that told me, yes, the transmitter on this thing is working correctly. So when we launch it, we ought to be able to track it. So this is a really clever use of the Whisper network to track the balloons. And in fact, the balloon that you saw, Bill Brown's balloon that went around the world 7 times, was transmitting on the Whisper system. And the flight that I showed you of mine going up over Canada and then down into the Bermuda Triangle was Whisper as well. Okay, so my final slide here, a couple of slides on shoot downs. There was a club in Illinois, you've probably read this, club in Illinois that launched one of these pico balloons, and they were tracking it. And as they were tracking it around the world, the last place that they saw it, K9YO-15, that was the amateur call sign that was on that balloon. Last place they saw it was right here, coming up on the coast of Alaska. And this was at night, so the transmitter went dead, and then they were expecting to pick it up the next morning. When it gets up north like this, the next morning often is late in the morning, because you have to wait for the sun to get up to a high enough angle that you're getting strong enough sun rays for the solar panels to activate. But they never heard from this again. What they did was they said, okay, using the Weather Service wind models, where would the balloon have gone during the night from this location? And it would have gone right up over the Yukon territory in about the location where the military tells us they saw this object and shot it down. And the fact that they've never heard a signal from it again could be that it went down in bad weather there in Alaska, or it could be it went down because of military things. We don't know for sure. Now, I have been told that a couple of days later, there were 2 or 3 more position reports from that balloon somewhere in the Pacific Ocean. And if so, that shoots that theory up pretty bad. But the other possibility is somebody could fake a signal, fake a packet, put it out on the computer servers, and it would show up on the map. So that's a possibility too. You know, this is not military grade encrypted or anything like that. So don't know. And then there was, let's see, there was one that was shot down over the northern edge of Alaska. And at first, some guys, WB0EMJ, thought that it might be theirs because they lost signal on theirs, but the timing was wrong for when it disappeared versus when the military said they shot it down. So we're not sure. I don't think anybody in the ham community has been able to link any of the other ones close to that, but that's a possibility. Oh, here's the prediction of where the balloon would have gone from that place where it was located based on the wind models. And it would have roughly been up where that yellow triangle is on February 11th, about the time military told us they shot it down. And my final slide, I guess the military now has come out with a determination what they'll call everything when they do identify it. But it's a little bit of humor.
Very good. Very good.
Anyway, so that is my run through on at least 3 of the aspects of amateur ballooning.
That's
Yeah,
great.
that's great. That's really good.
Yeah,
Let me ask you one clear question that comes out of all this is, and I know the pico balloon folks are kind of antsy about it, but I mean, we got to learn something out of this. Something was shot down. Obviously the Chinese balloon, but these other 3 objects, we got balloon crazy there, and you know, $500 million, whatever the cost was for Sidewinder missiles. What kind of regulations do you see coming, if any? Or are you? I know you had some concerns about some regulations that are going to, you know, price the whole STEM educational value out of the ballpark. But what do you see anything coming?
Yes, as far as the STEM flight goes, the STEM flights go, what we're concerned about is that they will put additional reporting or APR or ADS-B requirements on all those balloons. And that's going to make them a lot less affordable. And they could put requirements on like notification and permission from other 3-letter agencies prior to flight, and things like that. Frankly, I don't think the FAA is going to really crack down too much more than they have now. They seem to be pretty comfortable with the level of reporting that they're getting on the big balloons, and comfortable with the smaller balloons that it's not affecting their operations. Now, the pico balloon people have a concern, and that is that we're flying our transmitters over other countries. There are 3 countries in the world that do not allow amateur radio transmission in the skies above their country. One of them is North Korea. One of them, I think, is Somalia. And one of them is the UK. The UK, it's apparently, I'm thinking it's left over from World War II, but they do not allow it. So this Sky Tracker actually has geofencing in it and the logic in it to turn off the transmitter when it is over any one of those 3 countries. The other thing, if it's running APRS, is APRS frequencies are different in different countries. And so as it transfers from one country to another, it'll change its frequency so that it transmits. But I'm concerned that pico ballooning may get stifled in that we are agreeable that we won't fly our transmitters over other countries. And if you look at the maps, heaven forbid, there's pico balloons flying over China every day or every couple of days. So, so that's my thoughts, Leonard.
Yeah, I'm still, you know, to me, the big worry is still, and you said it, I mean, these things go to 40,000 feet. And that's where the Biden folks, you know, decided 40,000 feet was not a good altitude because of aircraft. And so it just, you know, yeah, just that to me is a worrisome thing. If these things are launched kind of willy-nilly, you know, it could be up there at 40,000 feet and some aircraft runs into one of these things, and then you're really going to be regulated. you're really gonna get it. So that 40,000 foot level is worrisome to me.
I
have a question.
If I can ask it. A couple years ago, Barb, David here, let us know about a bright speck of light in the sky, an hour or so before sunset. And we went out and looked at it, and I took a picture of it, and it seemed to be a balloon. So my question is, your two sizes of balloons that you use, how bright are they when they're up at 100,000 feet? What stellar magnitude, or how bright are they compared to the planet Venus? Or, I mean, did we see one of your kind of balloons, or did we see a Chinese kind of balloon that was much bigger?
Yeah, I think Carolyn was tracking that too, right?
Yeah, actually, I talked to the people who flew that balloon. It's a company out of South Dakota. And they were doing atmospheric steering with it. And it's a US based balloon. And it's a company called Raven Aerostar. It actually showed up on Flight Radar 24 we tracked it for almost a day.
Yeah.
So how bright was it? I
Oh,
mean,
I don't,
how
well,
big
I,
was
we
it?
only saw it at six.
Excuse me, how big was it?
I'll have to find out. I don't remember what they said. It was pretty big.
Yeah.
But Clark, yeah, I'm not a good judge of star brightness or anything, but during the day, we can look on our computer and it'll tell us it's at a azimuth of 74 degrees and an elevation of 54 degrees. So I'll make a rough guess at that and then tell the kids it's right up there somewhere. And the younger kids, they'll look around and spot it with their eyes. Me, I'm not so good at that. But if I get my binoculars out and scan around, I can catch it in my binoculars and see it. And I can see it once in a while.
So what we saw was considerably bigger because this was, anyone would see this. This was kind of brilliant in the blue sky. So that would have been a much bigger balloon.
Yeah, it might have been at a much lower altitude too.
Clark, I can probably find out for you because I have a contact card for the company. They said it was like the most tracked object they'd ever had up in the sky.
So Carolyn,
Actually-
this is Mark, was that one of the companies that was there at the conference?
Yeah.
Yeah,
They
I
were the
talked-
ones in the corner over, but just before you went around to the ballroom.
Right, yeah, I had a nice talk with those people. Very interesting
did
work
I.
they do.
Yeah.
Yeah.
Actually, I have a question for our speaker. When you were talking about students releasing on a deer trail, are you working with a fellow named Jeff Gagne?
No, out at Deer Trail, we just work with the school and launch from
Okay,
their
okay.
parking lot there.
Yeah, he was at the suborbital research meeting and talking about the student experiments that they're launching. And he lives in Colorado Springs and he's now taking over the planetarium at the Air Force Academy, but he's still doing the student flights.
Balloon launches, okay.
Yeah. And they're
Yeah.
basically out in the fields doing it, but they have to be east of DIA.
Yeah,
Carolyn, we launched from several different locations. As Jim said, Deer Trail is a prevalent one, but
Yeah.
since we preload where the things are going to go, we sometimes have to change the location fairly near the end because it'll show our original launch site is going to be too close to DIA airspace. The other thing I'm going to say is Ted Klein and Cheryl RQV, who's a member of the SkyWatchers here, put something on the chat. Very interesting, 11 times around the Earth for a pico balloon. And if you go there and click on the link that he showed, it will bring up information about that particular balloon.
Yeah, and Ted put up the link to Aerostar. I'm not sure that they mentioned that one flight that Clark was talking about that we all saw, but I did talk to them, and I think I can find out more about that flight. They didn't talk about the instruments. They just said that they were testing. It was part of a test flight that they were doing.
Yeah, I do have another question for Jim, I guess. You mentioned the three sources of balloons, the kind of ones that you're involved with, the pico balloons and the weather balloons. Is that basically the sum total of frequent balloon flights in the world or over the US? Or, I mean, are most student balloons included in that total, or are there still others? I mean, how many balloons are up over the North America at any one time?
Well, in addition to the various amateur clubs around the country that are, flying balloons, and individuals that are flying balloons, I think there's a bunch of people that buy a can of helium, a balloon, and put a iPhone on it and launch it and track it that way. There are some commercial, well, Google had the Loon project, and they were flying balloons around. And then, like Carolyn said, Raven Aerostar, they're doing experiments, and various companies are. The Weather Service is doing special studies. They're launching balloons. So yeah, I don't know what the numbers are. Leonard, we asked Bill Brown how many pico balloons are launched a year, and his guess was what, a couple hundred?
You're asking me to remember what I wrote. That's always dangerous. I can't remember what he said. We got it in there at the last minute when I was writing articles, but he turned out to be, one of these, to be honest, as a writer, when I first heard about this, I had no clue of what was going on. And it was really probably one of the most fun times I've had on doing research, because I had to go into a community. I had no idea who's who. I think it's one of the problems. I couldn't figure out who spoke in large mass for the pico balloon groups. The group that you're involved with, that you were, and the other guy was real responsive. But boy, I had a hell of a time trying to piece together what the community of pico ballooning really constituted. And I thought that was a little worrisome, because I couldn't figure out who's in charge here.
Well, what's your concern? I mean, are you concerned about just too many of them? I mean, I could understand if astronomers were worried, but what are some of the other concerns that you think about?
Airplanes running into pico balloons.
Well, yeah.
Sidewinder missiles being used to shoot down, unidentified aerial objects that we don't know what they are. And we never got to the third balloon was what, over Lake, what was that?
Huron.
Yeah, Huron. I don't know. And then you have the other sidebar going on here that I just read about today. You got generals up there on the Hill testifying about how the NORAD system doesn't work very well, and they had there's going to be a bunch of more money go into the ability to track objects. So there's all kinds of little offshoots from a pico balloon to congressional money going into defense of the country. So it's a huge arc of thinking and worry. So that's why I'm concerned about it. I'm kind of, I don't know if I'm going to write any more on it, but I mean, I did what I could do on my bit. But there's stuff to watch there, and regulations, and you know, who's in charge and the FAA, you know, they're gonna probably over-regulate if anything. They'll come up with, I'm not as optimistic about that. I think they're probably gonna do something. Somebody's gotta crack a whip somewhere.
Well, it sounds to me like these three smaller balloons that were shot down, they said that they were the size of a small car. I mean, that sounds to me like the size of any of these balloons we've been hearing about this evening. And it must be that those balloons are not dangerous because they're below the size and weight limit of the regulations Jim was telling us about. And
Yeah,
so I think they shot these things down for political purposes and they're not dangerous at all. When an
Or
airplane
panic.
runs into a flock of birds, it can become
Yeah.
dangerous, but that's a whole lot more weight than these typical balloons are.
yeah.
Well, that's interesting you bring up about the NORAD. I mean, that only tracks down to a certain altitude and certain size of object. So are they going to try and expand those limits?
They're already talking about new radar systems. Apparently they're antiquated radar, you know, and you know, we're worried about North Korea lobbing missiles in. I mean, we better get it together if we're that paranoid. And again, there just seems to be, if you really watch what's going on, if you go to the hearings and watch and read the testimony, this thing has legs going off in all directions, and it's going to cost the taxpayer quite a bit of money. You know,
It hurt science too.
yeah. So yeah, it's a great story, and you know, and go back to the Google Loon thing. I got conflicting views on, you know, what was Google Loon doing, and is that project over? They're not doing that anymore?
I believe they've shut that project down, yes.
What
Okay,
was that?
and maybe you could can you do a 5-second thing on what was it? I mean, what were they trying to do?
Well, my understanding is that Google Loon was a super pressure balloon with some steering capability in it. And there's a couple of ways that you can steer a balloon. One is you can have a bladder inside it that you can pump air into. And when you do that, it gets heavier and goes down. And if you know the wind patterns are going one way at a lower altitude, you can drop down to there and then you can climb back up, kind of like hot air balloon people do.
Yeah.
Or possibly big fans that push the balloon in a direction. One picture I saw of the recovered stuff from the Chinese 200-foot balloon, I think I saw a picture of like a 5-foot in diameter fan. And if that's the case, they may have been trying to push the balloon around with that. I don't know I don't think a loon was doing that. But I think Google was looking at it as possibly putting up balloons for an extended period of time and bouncing internet service off of them.
Right.
But it must not have been.
I don't want to, you know, discount China's, you know, thing, but when I go and look at Loon, I look at what the Chinese spy satellite, quote unquote, was doing, the antenna capability of that thing. I don't know. It looked like the Loon. It looked like, you know, I don't know. I'm not a big antenna guy, but I'm trying to find people that know antennas. And I you know, I'm not going to back the Chinese, but you know, that story just does not make sense to me at all still, of what the hell we shot down. And the fact that they got the recovered debris from shallow water, and we haven't heard anything about what is it. I mean, I put that out like the U2. I'm old enough to remember Gary Powers being drug up there, you know, with the U2. You know, okay, make the case and put the hardware out there. What were they doing?
So, yeah, so George, or I'm sorry, Jim, what else? You said you saw a fan. What else did you see in that debris?
No, that was all, I just happened to see one picture. I forget if it was on TV or
Oh,
what, but it just perked my attention that there was a fan in amongst all that. So maybe they were trying to doing some steering that way. I'm not an aerospace or an aeronautics person at all, but I don't think airliner crashing into a pico balloon would be a big deal at all.
Okay,
If, worst case, it would wrap around the leading edge of the wing. And at 500 miles an hour, I don't know how long the string would last before it broke. Worst case, I think would be if it was sucked into an engine, but they suck birds into engines routinely. Now, if you talk to the people in the Hudson River,
yeah,
they won't agree with you, but that was a whole flock of Canada geese, I believe.
yeah,
But I think those planes take goose hits periodically. And a pico balloon is much, much smaller than that. And these big balloons that we've got, if one or a couple of those pieces were to suck in the engine, it might disable the engine, but I don't think it's going to bring down the plane.
Jim, do you know if, Senator Kelly, I guess, I read on one of the websites, looked like he was gonna try to have a hearing or do some kind of legislation. Anything going on that? Have anybody heard anything?
I heard that he had proposed a bill. I don't know what stage of the bill process that is, but had proposed a bill that would require ADS-B on all amateur or all balloons.
Okay,
And that was a concern to the amateur community because number one, it would kill the pico balloon programs. Two, it would be quite expensive. And three, it would be additional weight on some of these smaller balloons that are maxed out as they are.
yeah. Well, and that gets to what I was worried about. Who is the voice of the pico balloon group?
Yes.
At some point, somebody's got to get up there if they have a hearing and do what you just did, which is give the, the benefits of the pico ballooning.
Yeah. There is no central authority for pico balloons, for ballooning, amateur ballooning at all.
Yeah.
There was a lot of email floating around on one chat group about what should we do as a balloon community? Should we, 1, 2, or 3, and one was be very aggressive in terms of lobbying with legislators. Number 2 was not lobby with legislators, but monitor carefully what's going on. And 3 was do very little and just keep an eye on things. And I think the vote was kind of for number 3.
Yeah.
I think these smaller research groups that are sending up a lot more balloons than we think, they're going to be the ones who would be complaining. I'll bet there are a lot of universities sending up stuff for different studies.
National Science Foundation.
Yeah.
The guys at LASP told me, we were out on a balloon flight one time, and National Science Foundation, down in Antarctica, the wind goes in a big circle around Antarctica. So you can launch a balloon and it'll float in the wind and it'll go around Antarctica for 2-3 months. And National Science Foundation was really proud because they had a balloon that lasted 90 days. And the LASP guys are going, crap, we did 121 days out there. And they said, shush, don't say anything. We don't want to piss off National Science Foundation.
Yeah.
So, Jim, this is Mark. Would it be practical to have some kind of a central place where all small launches were registered at, so it could just be there and could be checked hour by hour.
Yeah, I showed you that picture of the weather balloons all over the world, that cluster of the clusters at various places. That is a database where amateurs that monitor the weather balloons can put their data in, and it shows up on that map. There is a parallel database for amateur balloons, and those groups that put their balloons into that system, it shows up on the map. And several of our people said, hell, let's just tell the military, go ahead or the military is free to go ahead and watch that and look for where balloons are. And then we started thinking, but number one, not all balloons are reported to that system. And number two is this is an amateur system, is the quality control there assuring that all the data is, accurate and reported and archived, et cetera.
I
So
see.
there are some possibilities. It could be done, but we're not doing it in a professional manner, I guess.
Yeah, there's one other organization that I can mention. It's the DOE ARM program, the Atmospheric Radiation Measurement Program. They have sites around the world, and one in Oklahoma. One of their sites, temporary sites right now, is in Crested Butte, and it's part of what you mentioned. They do balloon launches twice a day, I think, for meteorological purposes.
Yeah, here's one of their beacons.
Yeah.
And it actually says ARM, has the ARM logo on the bottom of it there.
Yeah, that's one of the programs I used to work on.
Wow, okay.
Yeah.
So far, I've gotten one of these. I need to get some more. But
Right.
this is cute. It says on it, this is a weather instrument that measures air temperature, pressure. It was launched from Gothic, Colorado, as part of the U.S. Department of Energy's Surface Atmospheric Integrated Field Lab program. And it says, if you find it, you can keep it or throw it away. Don't throw it away in a fire because the batteries will blow up. And then it says in the summer, you can bring it to our RMBL Visitor Center in Gothic, Colorado for a free coffee or ice cream. For more information, visit the ARM website at DOE. Yep, so that's the program.
That's great. Yeah. I was involved in getting some solar radiation monitoring instrumentation installed there for that sale program.
Cool.
Yeah.
One thing you mentioned there about the cost of that, what, $2,500, it would seem to me that it's high because I would think the unit cost could come down if FAA regulations demanded it. Somebody would be competitive and lower that cost. I mean, you might, microchips the way they are, who knows what you could take that $2,500 and shrink that thing down.
Yeah, in fact, I think they're requiring them or talking about requiring them on drones. And our thought is if we can hang around for another couple of years, right, the costs will come way down based on that.
Oh, yeah. That's a good one. Okay.
So, yeah, one question, Jim, was you said you're running off and retrieving these things. What value, do they have some sort of value? What did they pay for those in the first place? Or some cases, us taxpayers, perhaps. But what's the original value? And then, besides getting a free cup of coffee, do they have value, or can you reuse them or reuse some parts?
Well, the old ones that they used to launch here from Denver, I had 6 of them hanging up in my Radio Shack just as souvenirs. I've given most of them away. but I'm not smart enough to reuse them for anything. But the Australian guys that wrote the software are smart enough, or a number of people are smart enough to reprogram these to use for amateur balloon flights. In fact, some guys in San Diego actually put a camera on one of these, reprogrammed it so it transmitted on the ham bands and sent pictures down from a balloon. So that's why I'm hoping to get hold of 2 or 3 of these so I can play with reprogramming these. But no, it's strictly a hobby thing. And it's just the fun of getting them and having them. It's kind of like geocaching. You know, geocaching people like to go out and track down the GPS, and, you know, I end up in people's yards. And I discovered if you put on a hard hat and a orange vest, you can go just about anywhere.
Good point.
Okay, we'll watch for you out in the driveway.
Yeah. Yeah. Another thing, you were talking about, a lot of these launches go from Deer Trail. Isn't that where the big model rocket people launch some of their rockets, American Rocket Association or some of the groups?
2 rocket groups I'm aware of. One, Northern Colorado rocket people, they go up to Pawnee grasslands and launch. And there's a group that launches down south of Colorado Springs somewhere. I've heard about those. I'm not aware of anybody out Deer Trail direction, but that may very well be. I'm not a rocket guy.
Yeah, that'd be fun to, you know, we went to one, I think it was north of Albuquerque, and those big rockets, you know, the ones that are, what, 6 feet or so much fun to see those things.
And
But
sometimes
that's over in a matter of a couple of minutes.
Yeah.
Balloons, we get 2.5 hours of fun.
yeah,
Hey, when I was a kid, I built a rock and I took a mailing tube and I stuck, you know, we made our own propellant, solid propellant, and stuck it in there and made a V out of some wood for it to take off in, and put a fuse from a firecracker in there and lit it and ran away. It blew that board to heck. It really made a big bang. It was a fail. And surprisingly, you know, boom, huge cherry bomb.
So George, you have all your fingers on both hands?
Yeah.
I guess.
Well, you know, the other last thing for me, and I'll shut up, but you know, clearly, you know, what Jim, you indicated there is kind of the competitive nature in a way of what pico ballooning people, whether they're races or, you know, where could this go? I mean, because I think, you know, with all the attention to it, more people would be interested in it, and they're going to try to do different kind of things, creative things, you know, it never ends. I mean, there's always somebody with a new idea, and pico ballooning may be just an avenue. So where could this go? Are there records out there to be set? Or new kind of ideas about using these things?
Well, I wonder if the next step in pico ballooning might be to put some sort of a sensor on it that collects ozone or temperature or something like that and report it back. Trying to keep it under half an ounce is, you know, pretty tough from an amateur standpoint. You know, with enough money, you could miniaturize it. Although one of the amateurs had actually made a pico balloon beacon that was, he said the circuit board was no bigger than a AA battery. And had the whole thing. So there's some pretty exotic stuff. But yeah, I wonder I don't know where it goes.
Well, you know, if you're familiar with Weather Underground, maybe Weather Underground should have a spin-off that's Weather Stratosphere.
Oh, yeah.
Oh, yeah.
Float up in the stratosphere for a long time. Yeah, a lot of the ballooning, it is long duration ballooning is a goal of a lot of people. So, these pico balloons have gotten to that point. And maybe we end up with space junk at 40,000 feet.
Yes, exactly. When I was quite a bit younger than I am now, one Christmas time, my dad came in with a parachute about 12 feet in diameter, orange and yellow, and enough nylon cording and enough plastic to last the rest of our lives. And he had seen something going down in the swamp. And so he called whoever, and they came out and he says, "Do you need it?" And they said, "Yeah." And he said, "Okay, go up the tree and get it." And they said, "No, you can have it." So he went up the tree and got it. But I don't know what it was. It must have been huge to have a parachute 12 feet in diameter.
Oh, wow.
It was monstrous.
So, Jim, one thing that I don't understand with the military shooting down the pico balloon over Alaska, whether
possible.
or whatever balloon it was, how was that really just one of these like party balloon size, or did they know? And how? No way they can use a $500,000 rocket, or, no matter the price, that big thing to shoot down a little tiny balloon, I would think it would miss, or it's
They
that
did
heat
miss.
seek. Yeah,
Well, they missed on one.
yeah, but that one that they said came down, they just couldn't get to the parts.
Yeah.
But, how is that possible? I guess is it a heat seeker, and so it's aimed at the balloon, or aimed at the materials, or metal seeker, or
I don't know if it's a Mylar balloon. Obviously they had to change those what are they? I forget what those missiles are called, but aren't they heat seekers that
Yeah, the
kind of-
Sidewinders.
Sidewinders go for a jet engine.
Yeah.
But I had an Air Force guy tell me that they might have been able to reprogram the targeting system on it, so it's going for the reflective balloon.
Uh-huh.
really? I still don't believe.
Why did one of them? They said was the size of a Volkswagen or a small car.
Yeah.
But one of these clear plastic balloons that was 2 feet in diameter and 7.5 feet long, at 400 miles an hour in a jet, you might perceive that as being the size of a small car.
That's exactly.
Yeah. Don't know, but I don't know what the military logic was for we need to shoot it. Well, I guess I do know what the military logic was. We got to shoot it down.
I think it was politics. Really, they were being criticized for not shooting down the Chinese balloon. So the first things they saw were these small balloons and went to shoot them down. The one over the Lake Huron, as I recall, the first missile missed it, didn't see it.
Right.
And it took a second missile to actually shoot the tiny little thing.
Yeah,
I'm more worried about that big heavy missile and where it went after that.
yeah.
Yeah.
And I have heard that you can't shoot them down with machine guns because the air pressure is so low that when you pop holes in it like that, the air leaks out so slowly. I think the Canadians tried that, and a balloon in Canada, and it came down in Finland or something like that. So
Yep.
it's not a good way to get them down quickly.
Mhm.
Yeah, we call them floaters in the amateur radio. Because sometimes, in fact, one of the balloons that we started to fill, we unfolded it, and there was a little circle on the balloon, and next to it was written "hole." HOLE was written. So we bought a balloon with a hole. That would have been a floater. It wouldn't-
Yeah. Mhm. Any other questions or comments?
Well, I kind of feel like I can't let this conversation go by without showing this one little couple pictures from my college days. I may have shown these at some time before. But you guys seeing that?
Yeah. Great.
Yeah, this is a hot air balloon that I made. A bunch of us in the dorms in college put this together. Those are actually trash bags that were welded together with an iron. And as you can see, it says HAB 5 on the side because this was our 5th attempt at this. But actually HAB 4 worked quite well. And in fact, this is HAB 4, but the middle 3 layers of trash bags were added to expand the balloon to be HAB 5. And this one really took off. We don't know. It was one of those things where it got high enough that you could be looking at it for 1 second, turn away, and you'd look back, and it was gone. And we were launching this from northern Florida, and it took off heading east pretty quickly after that. And my dad, who was a meteorologist in the Air Force, said, "Yeah, that probably caught a westerly," which would mean maybe 10,000 feet or something. So, you know, not 100,000. But that was still pretty fun. And I imagine all we did was we heated up with a charcoal fire. So it's just hot air. And then we tied off the bottom of it and let it float away. And my guess is it probably made it out in the Atlantic Ocean. I just wonder if some, you know, sailors or something came upon that and went, "What the hell is that?"
Yeah. There we go.
Go back one to the one with that triangle on it. Is that an antenna?
No, this great big thing here. Can you see my cursor?
Yes, yes.
Yeah, that's actually a crane that one of the guys on the floor built out of spare parts and scrap lumber in order to raise the top of the balloon up. And so it's all just held with guy wires, and he would swing around, and then there was a little button thing in the top so that we could raise the balloon up to vertical. And then we had a conical shape down at the bottom here with a charcoal fire in it. And that provided the hot air. So the guy who built the crane, we used to joke that if you dropped him off in a dump, he would drive out because he was just so good at, you know, kludging things together. But anyway, I figure for SkyWatchers, when else is this ever going to be relevant to what we're talking about?
No, I'm sorry I didn't remember that, Dewey. And anyone, you know, when you have something related to our talk, definitely bring in your pictures. Yeah.
I would think that with the surface color, that might have also obtained some solar gain for staying aloft. I went to the American Meteorological Society conference in January. It was in Denver, and there was one poster that had a large balloon that was painted black. So it was a solar balloon used for research. Kind of similar.
Yeah.
I had a friend, I've mentioned him before, Mark Adler, who used to work at JPL. For a while, I think this might have been while he was a student at Caltech, they were working on a balloon system they were thinking of using on Mars that was like that, where you would lay out the black balloon, and when the sun would come up, it would heat the balloon up enough to take off and drift around during the course of the day with instruments. And then at the end of the day, it would cool off and it would land, and then just, you know, every day it would wander around, you know, whichever way the wind was blowing. Mm. And they were just kind of experimenting around with that.
Anyone else?
Maybe we should launch a SkyWatchers pico balloon.
There we go. Let's do that. As long as it doesn't get up to 40,000.
Yeah.
falling up an
Yeah,
engine.
Our insurance for SkyWatchers is
Yeah.
under the Parks and Rec, but I don't think it covers that.
Can we paint the side of it like a big target?
Right.
Yeah, I don't know, my little ballooning adventure was because of Boys Life magazine. I don't know what year it was, but in Boys Life magazine, was like Life magazine, was really a large format magazine. And in there, they had an ad for a balloon you could buy. And it had a cartoon of the balloon above the earth, and I go, God, it can really go up high. And so I got that thing. It probably cost me $10 or 20 or something. And I get it in the mail, and I knew I was in trouble when the package came because it was so small. And you had to make the balloon out of these really thin gores, what they call gores, and you put them together and glue it together. It was like, I don't know what it was. It was like tissue paper. So I built this thing, and my science fair maniac that was like me, we went out and tried to get that thing off the ground. And basically, you had to hold it up in the air above a pipe where you had coals down there, and the heat would go up and it would expand, and I envisioned it will go into orbit, and he had to hold that thing on a pole to get the hot air in there, and nothing was happening. And I remember, the last thing I remember about that project was I put some kind of kerosene on the coals, and basically Jerry had a pole full of fire running around in a canyon. We didn't know what to do, and it was a disaster. So it cost me $20 to learn how to not do it.
That wasn't the one.
Leonard, I bought the exact same balloon when I was in junior high.
Did you?
That's great.
And I tried to fly out. This is when we were living in Colorado Springs, and a friend and I split on the cost. And we made a little rough stovepipe thing to get a little fire going and put the heat in it.
Yeah.
But we did it on a day that was too breezy.
Yeah.
And as you say, it's just tissue paper. And I remember being advertised as a 9-foot tall hot air balloon, and I envisioned, strapping myself to it and getting lifted up. And
that was flight 2.
yeah. And the breeze came along and it blew the balloon down and it ripped the whole thing lengthwise. And my buddy who I split on it, he still owed me his share. And once it was ripped, he goes, I'm not paying for it. So, but I actually kept it in my possession until I was I think it was probably my freshman year or just after I graduated from high school. And we had moved down to Florida. And my plan then was I had rigged a styrofoam mount for my Instamatic camera and my mom's kitchen timer to click the shutter button on the camera. And I remember we were having a swimming pool built in our backyard at that time. I got the thing all heated up and ready to go up with the camera, and it just kind of went up and then down into the swimming pool.
Yeah, really, I know.
Like, okay, that didn't work. So I got rid of the camera and I just tied a fishing line to it, a fishing pole, just to kind of keep hold of the thing so it wouldn't just drift away. We were, a couple hundred yards south of Patrick Air Force Base. So getting a balloon into the air probably would not have been a good thing.
Right.
But I remember getting to the end of the fishing line, kind of rocking back and forth, and it tilted up enough like this, you could see the dark smoke pouring out of it. I'm like, okay, it's done. and down it came. But the fact that you bought that same balloon, I really get a kick out of that.
Well, I canceled my
Life. Yep.
subscription after that. I never bought a thing from those people.
But I'll have to say that experience is probably why I thought I could do it with trash bags.
Yeah.
I know how to do it. I just need to make it bigger.
Yeah, that's it. That's right. Yeah.
Well, and they say you learn more from your failures than
Yeah.
your successes.
Yeah,
Yeah.
yeah, for me, failure is always an option.
So anyone else want to?
Yeah, I've done two different kinds of ballooning for work. When I was working in Arizona with an environmental consulting firm, we had projects at copper mines, and so to get data on wind directions, I would launch balloons. They were just a free flight balloon, and then I'd have to track them with a theodolite. So every few seconds, I'd have to get the crosshairs on the balloon,
Yeah,
and they would rise very quickly. It was very difficult. And so I'd have to read off into a tape recorder the degrees of elevation and direction, compass direction. But it was tough, had to do it day and night. And then I used to do tether sawn balloons for the Crested Butte project for AMAX molybdenum when they were doing an environmental impact statement project. So I was launching tether sawns, which is you just send it up and it has a transmitter on it that would give meteorological data and then bring it down. And so it was tough because I had to do that sometimes at night in the middle of the winter. It's quite cold, like -20. So tough working with those balloons.
that
You're
data
talking
is
about-
in the Smithsonian now, right?
Yeah.
You talk about using a theodolite to track the angle. It reminds me about the same age when I was in junior high. I was into flying Estes model rockets. And one of the things they sold was the altiscope that would measure how high your
Oh, yeah.
rocket went. And I had no idea how it worked, but I thought, well, that would be cool because I have no idea how high my rockets are going. And so I ordered the thing and it basically turned out to be a protractor. And, you know, it was a fancy thing with a little liquid in it so that you could sight the thing up and then clamp it so that you could then read the angle it was at. But that's all
You
it
gotta
was.
push a
And it's
metal
kind of like,
bar there.
okay, so to measure how high it goes, you need to get about as far away from the launch pad as you expect the rocket to go. So that, you know, you're in sort of 45-degree angle range. And I was very disappointed. I thought somehow magically I'd be able to stand at the launch pad and measure how high it went.
Yeah.
And just in case, some people don't know, you know, Mark, who's talking about that, recently retired from NRO, so National, what is it?
Yeah. National
Yes.
Renewable Energy Laboratory.
Laboratory, yeah, because I think some people need that, but yeah. So you did all those experiments under your job with them, right?
No, before I was at NREL,
Yeah.
when I was working for environmental consulting companies.
Okay.
Yep.
Well, anyone else? Comments?
I want to say something just quick. Is I remember from history, the Japanese in World War II sent incendiary balloons trying to set fire to the Northwest forest of the United States. It wasn't very successful, but there was an offensive use of these small balloons.
Oh,
One landed in eastern Fort Collins, and he had to keep quiet about it.
Oh,
So we think that was fun.
I saw one weird web comment from somebody when they look at the Chinese quote unquote spy balloon. When the missile hit, you know, there was this white powder and the guy's going, it's spreading anthrax. Who knows?
yeah. Well, this is great. Thank you, Jim and George, for.
Yeah, for jumping in on that for so
Yeah.
quick, yeah.
Yeah, and we had about 22 people on here, so that's a good turnout. I wasn't sure if people would do this every 2 weeks. So come on back in 2 weeks for Carolyn. Dude, that's,
Oh, are you still recording? If you're still recording, turn it off.
yeah,
Yeah.
let me turn it off. Right, and
I
then
have
John.
I have a non-balloon related comment. I was, during the talk, I was monitoring on my phone, YouTube of the reentry, parachute deployment, splashdown, and recovery of the Dragon